Welcome to today's lesson. Today I want us to look at grade 12 theorems. Now, before we look at the grade 12 theorems, there are a few grade 11 theorems that you need to remember. Because in grade 12, we are actually looking at areas of triangles. So here are some things that I want you to know about areas of triangles. Number one, if we have an acute angled triangle. Now remember that the area of a triangle is half base times height. Now, so if we want the area of the triangle, we can have a height. So we can draw a height this way, or we can draw a height this way, or we can draw a height that way. So if this is the height, then this is the base. But if this is the height, then this is our base. Whilst if this is the height, then that's the base. So we can have a height either way, and then we have that base. That's if we have an acute angled triangle. But suppose we have an obtuse angled triangle. So in that case, we don't draw the base anyway, the height anyway. So we will have to draw the height, and the height will be outside, and we draw it from the obtuse angle. So we extend, let's say we had our triangle as ABC. So now the base is still BC, but when we want the height, we'll have to do it outside. So we extend the outside there, and then we have our height, which is outside. Or we can extend it this side, and then we have our height there. So but the base is still a BC. So you see the difference. If it's a obtuse angle triangle, the height is extended outside. But if it's an obtuse angled triangle, the height is, we can do it at anywhere. So it's inside also. Right, now I want us to look at this theorem in grade 10 that states that if two triangles share a base and they are under the same parallel lines, so let's say this line is parallel to this line, and we have a triangle. So we say the triangle is ABC, and we have another one. So this other one there, maybe it's ACD. Now if we look at triangle ABC and ACD, because they're under the same parallel lines, then it means their heights are the same. So the height of this one is the same as the height because they are under the same parallel lines. And you can see they are also sharing a base. So they have AC, both of them, as a base. Now, we say these two triangles, ABC and triangle ADC, have equal areas. So we say that the area of triangle ABC is the same as the area of triangle ADC. Now we will give the reason as same base, same height, because they are under the same parallel lines. Same base, same height, because they are under the same parallel lines. So now when this is another we have another theorem in grade 10 which we call the midpoint theorem. So it's also important in this regard, the midpoint theorem. Now, we are not going to prove this theorem here right now, but the midpoint theorem states that if we have a line which is the midpoint of two sides of a triangle, remember a triangle has three sides. A triangle has three sides. So if we have a line which is the midpoint of two sides, so this is the line, it's the midpoint of this side, and it's also the midpoint of that side. Now the midpoint theorem states that this line is doing something to the third line. Number one, it is parallel the third side. So this line is parallel to this one. And number two, it is half the third side. So in other words, if this is x meters, this will be 2x meters. So that's the midpoint theorem. So we should remember it. It might help us in solving some of the problems that we will be doing in grade 12. So we call this the midpoint theorem. It's if a line is parallel is the midpoint of one side of two sides of a triangle, then it is parallel the third side and it is half the third side. So this is the midpoint theorem, right? And then the other thing that we should do a revision on, it's the ratios and proportions. So we will be talking about ratios and proportions. So it might be a good thing to just refer something about ratios and proportions. So now, without wasting any time, we are going to look at the first theorem in grade 12. Now the theorem states that a line which is parallel, a line parallel one side of a triangle, a line parallel one side of a triangle, a line parallel one side of a triangle divides the other two sides proportionally. In other words, in the same proportion. So let's see what is really happening here. So we have a triangle and we have a line which is parallel one side. So let's say our triangle maybe is A, B, C, and then we have our line as PQ. So PQ is parallel to BC. So this is the situation. Now we need to prove here, we are required to prove that it divides these other two sides in the same proportion. So now, in other words, we need to prove that AP divided by PB is the same as AQ divided by QC. So AP divided by PB is the same as AQ divided by QC. So this is what we want to prove, right? So now, as indicated before, we are going to be looking at the areas of triangles. Now, for us to remember what is it that we are going to do, we are going to calculate the area of triangle APB. So the required to prove part must actually lead us in remembering what we are going to do. So you see we have AP. It means as we look at the area of triangle APQ. So we know that is half base times height. So it's half. Now we want AP as a base. we want AP as a base, so it means we must construct a height that goes to AP. So as we have seen, that's our construction. We construct a height, so we can call it H. Now we are also going to construct a height that has AQ, so we can have another height there. So let's just call it, we can just say it's K. The height is K, you can give it any name. And then we are just going to join BQ and PC. Right, that is our construction. So we should not forget the construction there. So I think it's proper to write the construction. We will say the construction. We draw heights. We draw perpendicular heights H and K. We draw perpendicular heights H and K, and then we also join BQ and also PC. So that is our construction. Now remember, we want to prove that AP over PB equals to AQ over QC. So we said we want the area of triangle APQ. So we want AP as a height, therefore as a base, therefore H will be our height. So we say the area is half base, which is AP. So half multiplied by AP and then multiplied by height. In this case, the height will be the H. Now the PB will also guide us, so we look at the area of triangle PBQ. So we are saying the area of triangle PBQ, the area of triangle PBQ. So this will be half, and then PB is our base. PB is our base. So we realize that PBQ, it's an obtuse angled triangle. So we are going to construct a base for this one. Remember, we said that when we construct a base for this one, we must extend it to the obtuse angle. So we will extend this one and join. So already it's existing. We can see that this height is actually the height of this triangle. So therefore we just put the H as the height there. Right, so the area of triangle PBQ is half PB times H. Now if we divide the two areas, so we are going to get, can you see, the half will divide the half, the H will divide the H, and then we have the AP divided by PB. So it's like we have in this side. So now we continue. Now we want this side there. So we do the same. Whatever we did there, we do again. We say now we calculate the area of the same triangle APQ, sorry. So we will say the area of triangle APQ is half. Now we want the base as AQ. So we want AQ as a base, so the height will be K. So we'll have AQ times K. Right, now we continue. We want a QC now. So we calculate the area of triangle. We want QC, so QCP It's also half. Now it's QC multiplied by K also, as we look at it. PQC is, if we want the height, you can see it's the same height as this one. So as we extend it, so it's K also. Right, so the height is K. Now when we divide the two triangles, we will have something like AQ over QC. Right, so now we are going to look at that theorem of ours. Now if we take PQ as a base, we have triangle PQB and PQC. Now because the two triangles are under the same parallel lines and they have the same base, and it obviously means that they have the same height. So it means these two triangles have equal areas. So let's indicate them. So we will say the area of triangle, now we are saying, is PBQ. It's equals to the area of triangle QCP. Now our reason being, they have the same base, and they also have the same height, because they are under the same parallel lines. Now remember, you might forget which triangles we are talking about. So to remember the triangles that we talk about, you don't even have to bother looking at them here. You just take the triangles that are below, the triangles that are divided with. So in other words, you just come to your statement and say, okay, the triangle that is below is triangle PBQ. So you write the area of triangle PBQ, and the other one is QCP. So you write QCP. Now this will enable you to write these two statements and say this statement and this statement are equal, because if you check, the top triangle is APQ, even here it's APQ. Hence you needed to equate the two triangles below so that you are able to conclude that the area, of triangle PBQ, not PPQ, the top one, APQ, the area of triangle APQ divided by the area of triangle PBQ is the same as the area of triangle APQ divided by the area of triangle, our triangle which was below there, it's QCP. Right, so because of this statement, because the two triangles above are the same triangle, and then this statement indicated that the area of PBQ is the same as the area of QCP. So hence, if we have the same, these triangles there divided, it means this are equal. But remember, we said that the area of triangle APQ divided by the area of triangle PBQ, we said it is the same as AP divided by PB. So this is AP divided by PB. So that's this first side. So we said this is AP divided by PB, and this one, this area divided by this area is AQ divided by QC. So we will say it equals to this equals to AQ divided by QC, and this is what we wanted to prove, that these are in the same proportion. Remember, we say we have proved a theorem if the final statement is the same as the required to prove. So the required to prove, we were required to prove that AP over PB equals to AQ over QC. So that's our theorem. AP over PB equals to AQ over QC. And that concludes the proof of our theorem. So please don't forget to like, share, and subscribe. Thank you.